Now here, dear students, here we have the tasks regarding to the practical to determine the radius of curvature of a given spherical surface by use of spherometer. By use of spherometer. So last time I have pasted the video for you. Now today I will discuss the basic method that through how by use of the spherometer how can we discuss the measurement of the radius of curvature. Okay. So we have the need the apparatus required: spherometer, convex spherical glass surface, paper strip, along with the uh, skill is there. So I'm just showing the one of the basic that mean apparatus in front of you. This is the simply spirometer we have, and in which we have the different portions, and this one is a glass surface we have for which we want to make the radius of curvature. So definitely if the convex surface is there, so what is the meaning of the radius of curvature? That means distance of a pole to the focus is there. So that part we have, and this is the simplest. We have the glass left, because we are just taking the measurement on a plane surface as well as on a curved surface. Okay. So what is the basic concept of the spirometer on which it is based? It works on the principle of the micro screw meter. As the rotation given to the screw, it moves on a linear scale. Now there is the one of the formula of the radius of curvature given: L square upon 6h plus h by 2. L is generally the length between the legs of the spirometer. So we can easily find out. And now h height of the curvature surface. As simply we can make the measurement of the reading, as we are just comparing this one method from the last by the last two apparatus. So MSR plus 1 year constant into least count is the simply method we have. Now as we have done the screw gauge, so we have the concept of the least count, that is pitch upon number of division on a circular scale. So I am just showing the what is the main scale, what is the circular scale or the circular screw is there. So we have the one of the spirometer is there, and this is now the vertical scale which is mounted on it. This is called the main scale we have. Now this is the rotating screw is there, and these are the four tip points we have, in which three these are the three legs we have, and we are just finding the distance between the legs by pasting it on the paper. And this one is a circular screw which having the lower part, which was also the pin point is there. Okay. So simply the meaning of the pitch we have, as we are just giving the rotation to the screw, so it covers the linear distance on a main scale. So easily I have got that whenever I am just clockwise or anti-clockwise rotation, so I have mentioned easily the 5 rotations. So I have mentioned that it makes the coverance of the distance on the main scale, that is called the 5 mm is there. Okay. So and there are the 100 division, those are given on a circular scale we have. Okay. So a little bit we are just making the comparison of device with this screw gauge, and the linear scale which is given on a vertical strip, it is available in the part of the 20 mm is there. So whatever the measurement we are taking from the screw gauge spirometer, it comes in the part of a is there. And then in the last, whenever we are just making the measurement from the radius of curvature, so we will convert all the parameter into the centimeter, so we will get the idea. Okay. So as I have given the 5 rotation, so it covers the nearly about the 5 mm on the main scale. So the pitch comes in the part of the 1 mm, and the number of the division on a circular scale, these are the 100. So easily we can get the idea that what will be the least count is there. So in the part of the observation, I have mentioned the pitch is equal to linear distance on the main scale and the number of the rotation given to screw. So it comes 5 mm is to be divided by 5. So 1 mm linear distance pitch is there. As I am just solving it, so it comes the 0.01 mm is there. Now we have the task to make the observation table, and from which how can we make the measurement. Now, dear students, this is the measurement or the observation table we have, in which we are just taking the reading of the spirometer on the two portions. First is the plane surface, that is called the glass slab is there. Okay. Now the second surface, that is called the curved surface we have. Okay, on which we are just taking the reading of the spirometer is there. Okay. Now first the portion of the plane surface measurement of the h, that is on the plane surface, that MSR, vernier constant into least count, and that comes in the part of the is there. So this is called the h is there. Now on the curved surface I have mentioned the MSR, vernier constant into least count, and then I am just making the addition of that part, MSR plus vernier constant into least count. This also come in the part of the h dash, and definite on the curved surface we are just getting the more reading as compared to the plane surface. So we are just getting the subtraction of h dash minus h, then we are just finding the mean of that part. Okay, mean of that part. Okay, so only one reading I'll show to you, that how can we can measurement simply. Now this is the spirometer we have, and I have taken this one on a plane surface. Now I am just completely that taking the screw in a downward direction and touching it on the surface. So how can we it be I can say that there is a no kind of the, that mean gap is available, that mean between the surface and the pinpoint of the center screw. So I can easily understood that I am just putting a paper strip in the lower portion of a screw is there. Okay, so it is not that coming outside from the surface, as I am just taking this one paper strip between the lower portion of the screw, so it is not coming out from that part. Okay, so this is the actual portion we have. Now here we have to be make the conclusion. So definitely I am just getting the coinciding of the circular disc on a main scale, that is comes near about the 10 portion is there from the lower part. Okay, so the 10 is the reading is there, and then after we have to be make the calculation of a circular portion. So it comes near about the 20 is there. Okay, so it comes near about in the part of a 20, which I have mentioned here already. Okay, so this is the simplest portion of the h measurement is there, and then after we have the simplest calculation is there. Now I am just taking same how I am just taking this one on a curved surface. So definitely I have to be move the screw in a upward direction. Okay, so further I have to be stable this one spirometer on this surface. And further I have to be check the authority of the screw, that is stable on the curved surface. So a little bit gap is coming for the center screw is there. So I am just further adjusting it and taking in a downward direction on our curved surface. So further it is the paper strip is moving through the screw. So further I am just taking in downward direction. So definitely now at this time it's come very accurately. Now at this time I am just making the measurement of the reading. So it comes about near on the main scale, that is 11 portion is there, and same how already I have mentioned that the vernier constant that comes in a 25. So I'll repeat these readings one by one, definitely 4 to 5 times. I have mentioned all the portions here. Okay, so and then I have to be calculated the h dash minus h is there. Now I am just making the individual assessment of the all the reading, h on a plane surface, h dash on a curved surface. So I am just making the difference of that part, h dash minus h from the each set. So